An annuity is a series of equal payments made at an equal interval of time. So when we say annuity, we refer to those payments that are made in equal intervals of time. Examples of annuity are, so if we have amortizations, like for cars, for housing, for lot, and many more. We also have installments, like for loans, debts, and similar examples. So an annuity has 5 types. We have the ordinary annuity, annuity due. We also have deferred annuity. We have annuity with continuous compounding, and we have perpetuity. So these types of annuity differs on the cash flow diagram, specifically where first payment is made. So in this video we will discuss the ordinary annuity. Ordinary annuity is a type of annuity in which first payment is made at the end of first period. So how can we further explain this? So if you have a cash flow diagram, so this is your period 0. So this is your first period. So 1, 2, 3, 4, and so on up to n. So this is your first period from 0 to 1. So this is the first period. So this is the beginning and this is the end of the first period. So in ordinary annuity, your first payment starts here. So that makes ordinary annuity unique to other annuities. The first payment is made at the end of the first period. So, we have the formula for the ordinary annuity for the present worth, P, and the future worth. So, present worth, if you have the given A, your P is equal to A multiplied by the quantity of 1 plus I raised to n minus 1 over I times 1 plus I raised to n. So, take a look at this formula. So, this is the formula for the present worth. For the future worth, just copy the formula A multiplied by, copy the whole numerator, the quantity of 1 plus I raised to n minus 1 over, so you just have to remove this expressions on parentheses. So, the denominator here is only I. So, this is the formula for F. So, if you would notice, they have the same numerator, and in the denominator, the difference is that in F, you have to remove this. So, if in case you are going to look for the value of A given as P, just divide this bracketed expressions over P, as well as looking for A given as F, just divide this bracketed expression over F. So what are those elements? So present worth is P, future worth is F, A is the annuity or the equal payments, then your I is the interest rate per interest period. So just like compound interest, I is equal to R over M, where R is the nominal rate or the nominal interest rate, and M is the number of compounding per year. Your N is the number of payments. So these are the elements for the formula for ordinary annuity. Now let's try to answer an example. So for the ordinary annuity, so we have here a problem. A couple made a loan of 200,000 pesos to be made at uniform intervals at the end of each year for 10 years, starting at the end of first year. Nominal rate of interest is 4% compounded semi-annually. What will be the value of the uniform payment that the couple has to pay each year? So, let's identify the given. So, the couple made a loan of 200,000 pesos. So, your P is equal to 200,000 pesos. Now, it will be paid at uniform intervals at the end of each year for 10 years, starting at the end of first year. So the number of payments N is equal to 10. Nominal rate of interest is 4% compounded semi-annually. So we have the nominal rate of interest R equals 4%. And the number of compounding per year, M, is equal to 2. As it says, it is semi-annually. Find or what will be the value of the uniform payment the couple has to pay each year. So let's draw the cash flow diagram. So this will be your cash flow. So the couple made the loan 200,000 here at 0. Then starting at the end of the first year up to the end of the 10th year. So for 10 years, they will pay an equal amount of money. 8, 9, and 10. So they have to pay equal amount for 10 years. Now, what will be the value of the uniform payment? So we have here the form. So for the solution, so required is the value of A. Now we have the given P. So let's use the formula P is equal to A times the quantity of 1 plus I raised to n minus 1 over I times 1 plus I raised to n. So to solve for A, we write the equation to P over the quantity of 1 plus I raised to n minus 1 over I times 1 plus I raised to n. Now we have n, we have P, but we don't have the value of I. So notice that the payment is to be made annually. So one payment each year. But the compounding is semi-annually. So we have to equate the effective rate. Okay, so we have to equate the effective rate for annually and semi-annually in order to get the equivalent rate of interest. So for semi-annually, we have 1 plus R over M raised to M minus 1. Also here, 1 plus R over M raised to M minus 1. Now, for annually, we have 1 plus your nominal rate, your M is 1. Your M is 1 minus 1 equals semi-annually 1 plus your R is 4% semi-annual divided by 2 squared minus 1. So you can cancel this and equate. So your value of the nominal rate is equal to, so we have 1 plus the nominal rate annually plus 1 plus 0.04 over this 0.02 squared. So solve for the value of x. So the value of x is, or the nominal rate is 4.04%. So to solve for the value of I is equal to R over M equals 4.04% over 1 equals 4.04. So now we can substitute. So we have A equals P over the quantity of 1 plus I raised to n minus 1 over I times, your I is 0.404 times 1 plus I raised to n. So the value of A is equal to 200,000 divided by 1 plus I raised to n minus 1 over I times 1 plus I raised to n. So we have an annuity of 24,707.31 pesos. So this answers the value of uniform payment that the couple has to pay each year.